right, guys, in this slide, what's happening here is they've got this car going either to the left or to the right. And what we want to look at is its ending position. So for each of these cars, they're starting at 0 and they're traveling either left or right. So this first car, it says it's traveling to the right for 5 units per second and going for 3 seconds. So let's see, it would go 5, 5, 5, and end up at 15, at a positive 15. So in this case, positive is to the right and negative is to the left. They're looking for an expression. They're saying 0, that's our starting position, plus 5 groups of 3. So 5, whatever that unit rate is, for 3 seconds. For the second car, now we notice this one's going to the left, which means that it's going to go backwards. So again, starting at 0, it tells us the starting position is 0. It's going to go 4 units per second, whether that's meters per second or miles per second or however fast that's going, for 6 seconds. So let's see, it would go 1 second. After 1 second, it would be -4. 2 seconds would get us to -8. 3 seconds, 4 seconds, 5 seconds, 6 seconds. So we end up at, not at 24, but at -24 because it went to the left. Our expression is its starting position plus, maybe we say let's go -5 times 3. Nope, sorry, -6 times 4. Or we could say 0 minus 6 times 4. Okay, it ends up at -24. So fill in the other columns and then answer the question. All right, and for this slide, we've got a little situation going on. We have a traffic safety engineer is studying the travel patterns along a highway. She set up a camera and recorded the speed and direction of the cars and trucks that passed by the camera. Positions to the east of the camera are positive, so this way, positive. Positions to the left of the camera are negative, to the west of the camera are negative. Vehicles that are traveling towards the east have a positive velocity, and vehicles that are traveling towards the west have a negative velocity. So velocity is like speed, but with a direction attached to it as well. So a positive velocity means it's going to the right. A negative velocity means it's going to the left. I shouldn't say right and left, I should say east and west. So in this table, we're going to complete the table here with the position of each vehicle if the vehicle is traveling at a constant speed for the indicated period of time. And then we're going to write an equation. So the first one done for us. The first vehicle is traveling 25 meters per second. And we're looking at after 10 seconds after it passed the camera. Now we notice that the vehicle's traveling positive 25 meters per second, which means it's going to the right, to the east. Its ending position would be 25 meters per second times 10 seconds would be positive 250. We get that by doing 25 times 10 equals 250. So now we're going to do the same thing with the second car. And what I notice about the second car is that its velocity is -20 meters per second, which means it must be traveling to the west. So it goes to the west, 20 meters per second for 30 seconds. If it kept doing that 20 meters per second for 30 seconds, its ending position would be -600. Now that 600 is not a negative distance, it's its position relative to where the camera sits. The camera sits right at 0. So when we say its position is -600, we know that's 600 meters to the west of where the camera is. And its equation, we would do -20 times 30 equals -600. Okay, so fill out the rest of this for me.